Good morning. Today, let's start with a new chapter, chapter number 12, Exponents and Powers. Now, why we use exponents? In our day-to-day life, we come across many infinite numbers, which are very large or very small numbers. To express or write or represent such large numbers or very small numbers easily or in convenient way, we use exponents. Therefore, large numbers or very small numbers can be written conveniently using exponents. Now, we have learned what are exponents. General exponential form is a raised to n, where a is called the base and n is called exponent or power. Yes, example we can write 2 raised to 5, where 2 is base and 5 is power. Or you can write 3 raised to 7, where 3 is base and 7 is power, yeah, exponent. For example, it is given 35 crore. You can see here you need 10, 100, 1000, 10,000, lakh, 10 lakh, crore and 10 crore. So, 35 crore can be represented as 35 into 10 raised to 7. Here you can see 7 zeros, 1, 2, 3, 4, 5, 6 and 7. So, these 7 zeros we represent as 10 raised to 7. And the standard form of the same number is written as 3.5 into 10 raised to 8. This standard form we will learn in the later part of the chapter. But yes, either you can express the product of the same number again and again also in a convenient way in a short form. That is, for example, it is given here 2 into 2 into 2 into 2 into 2 into 2 into 2. That is, we have multiplied to 7 times. So, we can write it as equal to 2 raised to 7. That is, we have multiplied to 7 times. Or if we have to find out the prime factorization of a given number, that is, a number, for example, is given as 46,656. So, if we find the prime factorization of it, we will get that it is the product of 2 raised to 6 into 3 raised to 6. That is, if we multiply 2 6 times and then multiply 3 6 times, and the product of both will get is 46,656. So, we can easily in convenient way express large and very small numbers using exponents. Now, in till previous class we have learned only exponents with positive power. Let's see that if the power is with negative exponents. So, power with negative exponents, we know that 10 square can be written as product of 10 into 10. Here you can send 10 square, we write 10 into 10, that is 10 2 times, that we will get 100. Similarly, 10 raised to 1, that is 1 time 10 only. Either you can express it as 100 upon 10, where 0 0 will be cut and we will get 10. Or 10 raised to 0 equal to 1. We have learned this law that any base raised to 0 is always 1. That 1 we can again express as 10 upon 10, because this 10 and this 10 will cut and we will get 1 as it is. So, this is for positive powers. But what if it is a negative exponent with power? Yes. So, we get 10 raised to minus 1 as 1 upon 10. Yes. Minus 1 represents that it is 10 raised to minus 1 represents that it is reciprocal of 10. So, we write it as 10 raised to minus 1 as 1 upon 10. Here you can see that we have written 10 raised to minus 1 as 1 upon 10. Now, what about if we change the power? That is, if we write 10 raised to minus 2, That is, we can represent it as 1 upon 10 divided by 10. Yes, when zeros are increasing, we will multiply. When zeros are decreasing, we will divide. So 1 upon 10 divided by 10. Again this 10 we are converting as 1 upon 10. This division converts to multiplication, and this 10 will be the reciprocal of, we write as it, that is 1 upon 10. So we write 1 upon 10 multiply by 1 upon 10, that is equal to 1 upon 100, that is equal to 1 upon 10 square. Similarly, for 10 raised to minus 3, we take 1 upon 100 divided by 10, that is equal to 1 upon 100 multiply by 1 upon 10, that is equal to, you can see 1 ones are 1 and 100 multiply by 10, you will get 1000. So that 1000 again is nothing but 10 raised to 3. So we write it as 1 upon 10 raised to 3. Now we have 10 raised to minus 2 equal to 1 upon 10 square, or you can also write 10 square equal to 1 upon 10 raised to minus 2, or 10 raised to minus 1 equal to 1 upon 10 raised to 1, or converse of it, reverse of it, 10 raised to 1 equal to 1 upon 10 raised to minus 1. Similarly, if the base changes, then also no deal. You can write 3 raised to minus 2 equal to 1 upon 3 square, or 3 square equal to 1 upon 3 raised to minus 2. Here you can see that this and this are nothing but the converse of each other. 3 raised to minus 2 can be written as 1 upon 3 square, or we can also write 3 square equal to 1 upon 3 raised to minus 2. Similarly, if we change the base, that is, if we are taking 5 raised to minus 4, we can write it is equal to 1 upon 5 raised to 4, or 5 raised to 4 equal to 1 upon 5 raised to minus 4. When the denominator becomes when the numerator becomes the denominator, positive power becomes negative and negative power becomes positive. This is powers with negative exponents. So in general, we can say that for any non-zero integer a raised to minus n equal to 1 upon a raised to n, where n is a positive integer and a raised to minus n is the multiplicative inverse of a raised to n. Yes, so this is the general form of your power with negative exponents, that is a raised to minus n equal to 1 upon a raised to n. Yes, and a raised to minus n is the reciprocal of a raised to n. Now let's see some of the laws of exponents, which we are already aware in the previous class. Then also once let's recall the laws. So the numbers with negative exponents obey the following laws. Whatever laws were obeyed by positive powers, positive exponents, same laws are obeyed by negative exponents also. So the first law is the law of multiplication. Here you can see it is the law of multiplication, because we are multiplying, this is multiplication sign, we are multiplying two exponential forms. So this is called law of multiplication. What does the law states? The law states that any two exponential forms, when multiplied in such a way that their base is same, here you can see the base is a, here also and here also base is same and powers are different. Here you can say power is m and here the power is n. So the exponential forms having same base and different powers, when multiplied, we get the product as base raised to power plus power, or you can say in short that a raised to m multiplied by a raised to n equal to a raised to m plus m. So in multiplication of exponential forms where base are same and powers are different, we have to add the power. This is the law of multiplication. Next law is law of division. Here also only the difference that there we are multiplying, here we have to divide. So what will happen? So when exponential forms with same base and different powers are divided, here you can say we have taken base same a and powers are different m and n. So a raised to m divided by a raised to n equal to a raised to m minus n. Here we are subtracting the powers. Yes. So the law states that when exponential form with same base and different powers are divided, powers are subtracted. Third law, that is a raised to m multiplied by b raised to m. Here you can see the difference of exponential powers is that here the base is different. Here the base is a and here the base is b. Yes. So when exponential forms with different base and power are same, here you can see power both are m. So exponential form with different base and same power are multiplied, then we have to take the product of the base raised to power. That is, we will write in short as a raised to m into b raised to m equal to ab whole raised to m. We will multiply the base a and b and then we will give the power as m. Yes. Then the next law is any base raised to 0 is equal to 1. That is, a raised to 0 equal to 1. This is the next law. Any base raised to 0 is 1. Another law is power raised to power. That is, a raised to m raised to n. That is, already you see that we know that exponential form is having a power, and that also again is raised with another power, that is a raised to m raised to n. Then nothing, we have to multiply the power, that is a raised to m in raised to n equal to a into a raised to m into n. This is the law of power raised to power. Again I repeat the power, that if any base raised to power and that again raised to power, then the powers are multiplied. And the last law is a raised to m upon b raised to m, which is equal to a upon b whole raised to m. Means if different base with same powers are divided, we will divide the number with the same power. Yes. That is, we write a raised to m upon b raised to m equal to a upon b whole raised to m. Now, let's use all this and solve the exercise. So, exercise 12.1, question number 1, evaluate. Evaluate means you have to find the value. Solution for question number 1, as there are different questions in question number 1. So the solution for question number 1, it is given as 3 raised to minus 2. We have learned right now only how to express the powers with negative exponents. That is, we will write is equal to 1 upon 3 square. Yes, 3 raised to minus 2 is reciprocal of 1 upon 3 square is the reciprocal of 3 raised to minus 2. That is equal to 1 upon 3 square, that is 3 multiplied by 3. That is, we will get equal to 1 upon 9. Next, question number 2, minus 4 raised to minus 2. Again, we write the reciprocal of it, that is equal to 1 upon minus 4 raised to 2. Negative power becomes positive. That is equal to 1 upon minus 4 multiplied by minus 4. We split the power, that is 2 times will multiply minus 4. That is equal to 1 upon 16. Yes, because 4 4s are 16 and negative multiplied by negative becomes positive. Next, question number 3, 1 upon 2 whole raised to minus 5. Again first we apply the law, that is a upon b whole raised to m equal to a raised to m upon b raised to m. So we first split the power into numerator and denominator, that is equal to 1 raised to minus 5 upon 2 raised to minus 5. Again we write the reciprocal of both, so it will become 2 raised to 5 upon 1 raised to 5. Reciprocal is 2 will come up with positive power and 1 will go down with positive power. As we turn the reciprocal, powers becomes positive. That is equal to 1 raised to 5 times 1000 times, it will remain 1 only, and we don't take base as denominator as 1, so that is equal to 5 times, that is 2 into 2 into 2 into 2, that is will give 2 2s are 4, 4 2s are 8, 8 2s are 16, and 16 2s are 32. Next question number 2. Simplify and express the result in power notation with positive exponent. Now here we have to simplify the given question and write the answer with positive exponent. So question number 1 of it, minus 4 raised to 5 divided by minus 4 raised to 8. In division, powers are subtracted according to the law of exponents. So we will write directly minus 4 raised to 5 minus 8, because we have learned a raised to m divided by b raised to m n equal to a raised to m minus n. See, that same law we apply here, that is minus 4 raised to 5 minus 8. Here you can see first power is 5, so 5 minus second power is 8. That we will get minus 4 raised to minus 3, because 5 minus 8, that is minus integer, is bigger than the positive integer. So we will take the sign of minus, and 8 minus 5, that is 3. So we will get minus 4 raised to minus 3. This, as it is having a negative exponent, we will convert it into positive, that is we will write the reciprocal of it, that is equal to 1 upon minus 4 raised to 3. Question number 2. 1 upon 2 raised to 3 whole square. Yes. Again we apply the law, a upon b whole raised to m equal to a raised to m upon b raised to m, that is equal to 1 square here upon 2 raised to 3 whole square. 1 square will become 1 as it is, and 2 raised to 3 whole square. Again power raised to power, that is a raised to m raised to m. So we have to multiply the power, so we will get equal to 1 upon 2 raised to 3 into 2. We will multiply the power in the denominator, so we will get equal to 1 upon 2 raised to 6. Next question number 3. Minus 3 raised to 4 into 5 upon 3 raised to 4. That is equal to minus 3 will, you can see base are different and powers are same. So we have to multiply the base, and power we have to put it on the product of the bases. So we will write minus 3 into 5 upon 3 whole raised to 4. Yes. This we have multiplied the bases, and power we have taken out as common outside. That on further we will get, as you can see, we can cut 3 ones are and 3 minus ones are. Yes. So we will get minus 1 into 5 whole raised to 4. That is, again we will split the powers, that is minus 1 raised to 4 into 5 raised to 4. As the base is negative and power is even. Yes. So we will get the product as positive only. That is minus 1 multiplied by minus 1 multiplied by minus 1 multiplied by minus 1. We have to multiply minus 1 4 times. So we will get positive 1. So that is 1 into 5 raised to 4. That is 5 raised to 4. Next question number 4. 3 raised to minus 7 divided by 3 raised to minus 10 into 3 raised to minus 5. First, we have to solve the bracket and then we will solve the remaining part of the given question. It is the rule that whenever bracket is given, first we have to solve the bracket. You can see in the bracket that base 3 are same and powers are different, and there is division between both the exponential forms. So we will apply the law of division, that is, law of division states that you have to subtract the powers. So we write 3 raised to minus 7 minus 10 and multiply by 3 raised to minus 5 as it is. Now we have to subtract the powers, so when minus will become plus. Here you can see these two minus are there, that will become plus. So we get 3 raised to minus 7 plus 10 into 3 raised to minus 5. That is 10 minus 7 we will get 3, that is 3 raised to 3 into 3 raised to minus 5. Again you can see that we can apply law of multiplication, that is same base when with different powers, when multiplied powers are added. So we write 3 raised to 3 minus 5. Here we have to add the powers. So 3 plus minus 5 will directly get 3 minus 5. That is 3 raised to minus 2. Again this is negative exponent, so we'll convert it into positive, that is we'll write the reciprocal of it, so we'll get equal to 1 upon 3 raised to 2. Here you can say 1 upon 3 square. Next question, find the value of. Here also you have to find the value of given questions. Now solution for question number 1. Question number 1 is given as 3 raised to 0 plus 4 raised to minus 1 into 2 square. First let's solve the bracket. Now any base raised to 0 is 1. We have learned the law, so we'll write 3 raised to 0 as 1 and 4 raised to minus 1, that is reciprocal of it will be become 1 upon 4 into 2 raised to 2. Again as you can see 1 plus 1 upon 4 we have to take the LCM, so we will write 4 plus 1 upon 4 into 2 raised to 2. That is 5 upon 4 and 2 raised to 2 is 4 only, because square of 2, that is 2 into 2 will get 4. Here you can cut 4 and 4, so we'll get on simplification the answer is 5. Next question number 2. 2 raised to minus 1 into 4 raised to minus 1 divided by 2 raised to minus 2. Here you can see that first we will solve the bracket. So here base are different and power are same. So we will use that law. We will multiply the base, that is 2 into 4 whole raised to minus 1 and divided by 2 raised to 2 minus 2 as it is. Again solving the bracket we will get 2 into 2 square whole raised to minus 1 divided by 2 raised to minus 2, because 4 is nothing but square of 2. That is same base and different powers are added. So we will write 2 raised to 1 plus 3 whole raised to minus 1. Inside the bracket we will continue to solve and power will remain as it is till we are completing the solution of inside the bracket. So we will write 2 raised to 1 plus 2 whole raised to minus 1 divided by 2 raised to minus 2. Again 1 plus 2 is 3, that is 2 raised to 3 minus 1. 2 raised to 3 raised to minus 1 divided by 2 raised to minus 2. And 3 into minus 1 we will get minus 3. So we will write 2 raised to minus 3 divided by 2 raised to minus 2. Again same base and different powers, when divided powers are subtracted. So we will get 2 raised to minus 3 minus 2. Yes, again this minus minus will become plus, so we will write 2 raised to minus 3 plus 2. Here you can see 2 raised to minus 3 plus 2, that is 2 raised to minus 1, that is equal to 1 upon 2. Here it is 1 upon 2. Yes, because reciprocal of 2 raised to minus 1 is 1 upon 2. Next, question number 3. 1 upon 2 whole raised to minus 2 plus 1 upon 3 whole raised to minus 2 plus 1 upon 4 whole raised to minus 2. Here first we split the powers, that is 1 raised to minus 2 upon 2 raised to minus 2. Similarly, plus 1 upon 1 raised to minus 2 upon 3 raised to minus 2 plus 1 raised to minus 2 upon 4 raised to minus 2. Then we take the reciprocal of the negative powers, that is it will become 1 upon 1 raised to minus 2 will become 1 upon 1 square. Yes, and 2 raised to minus 1 will become 1 upon 2 square, that is 2 square will come up and 1 will go down, so we write it as 1 into 2 square upon 1 square into 1. Similarly, for 1 raised to minus 2 we will write 1 upon 1 square, and for 3 raised to minus 2 we will write 1 upon 3 square. Again 3 square will come up, so we will get 3 square upon 1. Similarly, for 1 raised to minus 2 the reciprocal is 1 upon 1 square, and for denominator 4 raised to minus 3 the reciprocal will be 1 upon 4 square, where 4 square will come up and 1 will be written as down. Here you can see. Yes, that is, you can see that all the denominators are having 1, so we will don't write it, and we will get equal to 2 square plus 3 square plus 4 square. Let's open the powers, that is 2 2s are 4, 3 3s are 9, and 4 4s are 16. That is 4 plus 9 plus 16, that is equal to 29. Next, question number 4. 3 raised to minus 1 plus 4 raised to minus 1 plus 5 raised to minus 1 whole raised to 0. As the powers are negative, we will write the reciprocal, that is 1 upon 3 plus 1 upon 4 plus 1 upon 5 whole raised to 0. That is equal to, we will take the LCM, so we will get 20 plus 15 plus 12 upon 60 whole raised to 0, that is equal to 47 upon 60 whole raised to 0, that is equal to 1, because any base raised to 0 is always 1. Question number 5, that is minus 2 upon 3 whole raised to minus 2 again whole raised to 2. Yes, here it is again power raised to power, so first we start solving with the outer parts, that is we will multiply this power raised to power, so we will get minus 2 upon 3 whole raised to minus 2 multiplied by 2. Multiply these powers, power raised to power, that is minus 2 upon 3 whole raised to minus 4. That is, we split the powers now, that is minus 2 raised to minus 4 upon 3 raised to minus 4. Again reciprocal of negative powers, so 3 will come up with positive power and minus 2 will go down with positive powers, that is 3 raised to 4. Here you can see 3 raised to 4 upon minus 2 raised to 4. Expanding it, we will get 3 into 3 into 3 into 3 upon minus 2 into minus 2 into minus 2 into minus 2. That is 3 3s are 9, 9 3s are 27, and 27 3s are 81, and minus 2 into minus 2, that is 4. 4 into minus 2, that is minus 8, and minus 8 into minus 2 we will get 16. So we will get 81 upon 16. Dear students, please copy all this in your regular CW with neat and clean handwriting. Remaining part of the exercise will continue in the next session. Thank you.